product of primes and indices. Don't think this will come up, but just in case. 2 times 6 is 12, x to the 4 times x to the 2 is x to the 6, and y to the 6 times y to the 3 is y to the 9. Simplify 81 to the power of minus 3 over 4, so this is 81, 1 over 81 to the power of 3 over 4. So this is the 4th root of 81, then cubed. So the 4th root of 81 is 3, and 3 cubed is 27. Remember, you've got the calculator to help you with this as well. Express as a product of prime factors, so 1, 3, 2, 3. It's not an even number, so 3 will be the first one. Use the calculator to help you. Divide by 3, you get 4, 4, 1. See if that will divide by 3. It does, so we get 3 and 1, 4, 7. See if that will divide by 3. It does, so we get 3 and 49. And the 49 is made up of 7 times 7, which are both prime numbers, so we get 3 cubed times 7 squared. To make this a perfect square, all these powers have to be even. So we would need an extra 3 in this tree to make that 3 to the power of 4. So we would have to times it by 3 to make it a perfect square. 5 4s are 20. C to the 6 times c to the 9 is c to the 9. And d to the 4 times d is d to the power of 5. Slightly more complicated of all of these. So the first thing you have to do is expand the bracket. So in fact, we can do it easier than that. We can divide 21 by 7, which gives us 3. A to the 7 over 2 divided by a to the minus 3 over 2. Subtract, so we get 7 over 2 minus 3 over 2, which makes plus, so this is 10 over 2 for a, and then this bracket is the same on top and bottom, so then we can do the same thing here, which is minus 3 over 2 minus 5 over 2, which makes minus 8 over 2. We can simplify this slightly because 10 over 2 is 5 and 8 over 2 is 4. 792 is a product of primes. 792, it's an even number, so it will definitely divide by 2. 396, again another even number, so it will definitely divide by 2. 198, keep dividing by 2 as far as we can. 99, that's not going to divide by 2, but it will divide by 3 to give 33, which will divide by 3 with 3 and 11, which are both prime numbers, so we get 2 cubed times 3 squared times 11. Again, to make it a perfect square, we need even powers, so we'd have to have another 2 in here to make it 2 to the power of 4. We have an even power here, and we'd need another 11 in the tree to make it, obviously, 11 squared, so we'd have to multiply by 22. Why it's not a perfect square? Because 2 to the power of 5 has an odd power. Indice rules, 4 to the minus 2 is the same as 1 over 4 squared, which is 1 over 16. Any to the power of 0 is 1. Root times itself is just the number, and then we get that again here. 3 to the power of minus 4 is 1 over 3 to the power of 4, which is 1 over 81. 2 to 5, it's not an even number, so divide it by 5. 45, and then again divide by 5, 5 and 9, and then 9 is not prime even, and then divide it, get 3 and 3, so we get 3 squared times 5 squared. Reciprocal of 0.7 is 1 over 0.7, so then times top and bottom by 10 to get 10 over 7. Estimate the value of 9 root 902. Well, you should know that the square root of 900 is 30, so an estimate would be 30. Write down the square number which is closest to 90. 81 is 9 away, so it will be 9 9s are 81. Standard form, again, something I'm not convinced will come up, but might do. So 5.3 times 10, and then count how many times it's moved. 1, 4, 7, 10 places, so it's to the power of 10. This one, 2 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, but we've gone the other way, so it's minus 9. Find in standard form the values of these, so times them together, and in fact we can just put them in as standard form on the calculator with this paper. So then it'll be 7.3 times 10 to the power of minus 4, and we find that the answer is 4.964 times 10 to the power of minus 8. Again, the next one, just type it in, 3.7 times 10 to the power of minus 5 times by 8.2 times 10 to the power of minus 6, 3.034 times 10 to the minus 10. The mass of Earth is that, and the mass of the Moon is this. How many times more is the mass of the Earth than the mass of the Moon? So we're going to do the mass of the Earth, and we're going to divide it by the mass of the Moon. So 6.0 times 10 to the power of 24 divided by 7.4 times 10 to the power of 22. So we find that that's 81.08. So to the nearest whole number, that would be 81 times the mass of the Moon. Write down the following number in standard form. 3.4 times 10 to the minus 1, 2. 6 million is 6 followed by 6 zeros, so it would be 6 times 10 to the power of 6. Again, we've got a calculator for this one, so 4.5 times 10 to the power of 17 times by 7.8 times 10 to the power of minus 11 will give us 3.51 times 10 to the power of 1, 2, 3, 4, 5, 6, 7. Be careful here on the calculator, that came up as a whole number without standard form, but they asked for in standard form, so you have to change it yourself. 1.45 times 10 to the power of 11 divided by 8.43 times 10 to the power of minus 4. That comes out as 1.72 times 10 to the power of 14. This one, 1.2 times 10 to the power of 2 to the power of 6 times by 6 to the power times 10 to the power minus 2. 1.2 times 10 to the power 1, 2, 3, 4, 5 again. Be careful because on the calculator that doesn't give you it in standard form. Trial and improvement. So a solution lies between x equals 1 and x equals 2. So we have x values, the answer to x cubed plus 2x minus 5, and then whether it's small or large. So start off by checking 1 and 2. So 1 cubed plus 1 is 2 minus 5 is minus 3. 2 cubed is 8 plus 4 is 12 minus 5 is 7. They are either side of 0, so that's correct. Try 1.5 next. 1.5 cubed plus 2 lots of 1.5 minus 5. That is 1.375. We're still, so we're small there, large there, and we're still large here. So anything in here must be irrelevant. So I'm going to try 1.4. So I've got 1.4 cubed plus 2 times 1.4 minus 5. That comes out as 0.544. Still too large. I'm going to go slightly smaller at 1.3. 1.3 cubed plus 2 lots of 1.3 minus 5. That's minus 0.203, so that's too small. So my answer is between 1.3 and 1.4. So to make sure, I check 1.35. So 1.35 to the power of 3 plus 2 lots of 1.35 minus 5. That comes out as 0.16, which is too large. So to one decimal place, 1.3 must be the answer. Second one, slightly longer just because it's a slightly harder set of numbers. Same method though. X, 5x cubed minus 82x minus 45, and then small or large. Check 4, check 5 to make sure. So 5 times 4 cubed minus 82 times by 4 minus 45. Ooh, careful because I've typed it in wrong. And that comes out as minus 53, so that's too small. Check it with 5. And I find that's 170, which is too large. So I check 4.5 next. That's 41.6, so that's still too large, so anything in here would be. I'm going to go for 4.3 next. So I change it to 4.3. And I find that that's minus 0.065, so that's too small. I have to do 4.4, which I'm hoping then will be large, and I will have the 4.3 and 4.4 one decimal apart that I need. So 4.4 comes out as 20.6. 0.12, and that is too large. Although it looks pretty clear that 4.3 is going to be the answer here, you do have to get the full 4 marks, check 4.35 to make sure. So although it looks quite obvious from the values that 4.3 will be the answer, to prove it you do have to go one further. That comes out as 9.8, which is too large, so 4.3 is the answer, but you did have to check it. A couple more trial and improvements. So, slightly different this time because they want you to go to 2 decimal places. So x cubed plus 3x minus 8, and then small or large, 1.5 and 1.6. So again, we need to start off by doing 1.5 to the power of 3 plus 3 lots of 1.5 minus 8. Not only have you got to do this to make sure you get the first mark, it does help you to make sure you are definitely typing it incorrectly on the calculator, because were you to type it in wrong, you would find that that first one might actually come out as being too large, and that's obviously not able to happen. So 0.896 too large. In the middle is 1.55, so we change this on the calculator to 1.55, and we find that's 0.37. So everything in here then is too large. I'm going to try 1.53 next. And that comes out as 0.17, so that is still too large, so I'm going to go to 1.52 next. So I'm going to put 1.52 into my calculation, and I find that's 0.07. That's still too large. I'm going to have to do 1.51 now, even though I haven't got space. I'm going to have to do it to make sure where the change of sign happens. So that is minus 0.02. So the change is between 1.51 and 1.52. So I check 1.515. And I find that's 0.02, which is too large, so this is the answer. Explain why it has a solution between 1.4 and 1.5. All I need to do here is I need to put in 1.4 and find the value, and I put in 1.5, and then if there's a change of sign, that proves that it must be the solution is between those two values. So I'm going to put in 1.4 comes out as 19, oh no, yeah, that comes out as 19.04, and then I'm going to change it for 1.5, and that comes out as 22.875. Now, one solution is below 20 and one is above 20, therefore there must be a solution in between.